Hello everyone, welcome to Explore Hop. So for this example, we're told that a box contains 4 balls, numbered 1, 2, 3, and 4, and 2 balls are drawn from the box without replacement. Then we let E be the number of even-numbered balls drawn. Construct a probability function for E. So let's first start by constructing a tree diagram to visualize all possible outcomes of this experiment. As we've seen before, since we are choosing the balls without replacement, then we obtain the following tree diagram. Now, we can list all the possible outcomes in the sample space. So, the sample space is therefore the set containing the outcomes 1, 2, 1, 3, 1, 4, 2, 1, 2, 3, 2, 4, 3, 1, 3, 2, 3, 4, 4, 1, 4, 2, and 4, 3. And from here, we can see that we have 12 possible outcomes. So there are 12 possible outcomes. Now, let's determine the probability of each value of E. So since E has to be non-negative, we first start at 0. And since we only have 2 even numbers, now let's determine the probability of each value of E. So since E has to be non-negative, we first start at 0. And since we can only have at most 2 even numbers, then the largest possible value of E is 2. So we will find the probability of each value of E from 0 to 2. So, to find the probability of E being equal to 0, which is the probability of having no even numbers, we take the total number of ways to have no even numbers and divide it by the total number of possible outcomes. So from the sample space, we see that we have 0 even numbers over here and 0 even numbers over here. And so that gives us 2 outcomes in the sample space with 0 even numbers. So the probability of E being equal to 0 is therefore equal to 2 over 12, which is equal to 1 over 6. Now let's find the probability of E being equal to 1. So this is just the probability of there being one even number. And once again, we first need to determine the number of ways to have one even number. So from the sample space, we see that we have one even number over here. 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 And so if we were to count all of these outcomes, we get 1, 2, 3, 4, 5, 6, 7, 8. 8 outcomes with one even number. So the probability of E being equal to 1 is therefore equal to 8 over 12, which is equal to 2 over 3. Now let's find the probability of E being equal to 2, which is the probability of having 2 even numbers. And we can see that the 2 remaining outcomes in the sample space, so this outcome over here and this outcome over here, have 2 even numbers. Thus, the probability of E being equal to 2 is therefore equal to 2 over 12, which is equal to 1/6. So now we can represent the probability function for E using a table. So after creating a table, we can list all possible values of E on the left-hand side and the value of the probability function for each value of E on the right, so f of E. So we'll start at E equals 0. So when E is equal to 0, the probability of E being equal to 0 is 1/6. So that's the value of the probability function for E equals 0. Now for E equals 1, the value of the probability function is 2/3. And for E equals 2, the value of the probability function is 1/6. And that's the probability function for E. Thank you for joining us. See you in the next lesson.